Okay, in this problem we want to find and classify the critical values for f parentheses x comma y is equal to x cubed plus 6xy minus 2y squared. And in the last couple of videos we went over this reference table in order to determine and classify the value. So let's get started. The first thing we're going to do is get the partial derivative in terms of x. And when we do that, we would get 3x squared plus 6y. Likewise, we need to get the first partial derivative in terms of y. And when we do that, we would get 6x minus 4y. Next, we get the second partial derivative. So fxx, this would equal 6x. This is important, so I'm going to underline it. And we also do fyy. And when we do that, we get negative 4. Likewise, fyy is also important. And we have to get fxy. fxy, we can take the partial derivative of this in terms of y. And so we would get 6. Another important term. And now we need to get the critical values. So we set fx is equal to 0. We also set fy is equal to 0. So fx is equal to 0. So 3x squared plus 6y is equal to 0. And we can't really factor this out since we have two unknown terms, x and y. So we'll see what we can do with y. So we can say 6x minus 4y is equal to 0. So you can say f4y is equal to 6x. So let me scroll down a bit. And so we can conclude that y is equal to 3/2 x. And now we will apply this into our first equation. And when we do that, we would get 3x squared plus 9x is equal to 0. And now we can factor. So we can say 3x parentheses x plus 3 is equal to 0. And so our critical value can be x is equal to 0 comma negative 3. And we will apply this to get our y corresponding term. So we plug back into here. And we can conclude our critical value would be when x is 0, y would be also 0. And when x is negative 3, our y would be negative 9/2. And so we want to classify the value. So let's do that. So we will construct a table. So we'll have a critical point C dot P. Our formula to classify, so D, our fxx, and our conclusion. And so we are saying for our two critical point, that is 0 comma 0 and negative 3 comma negative 9/2. So those 2 points we'll be testing. So we go up. Our original equation of fxx. So we plug in 0 for x, which is going to be 0. Now we do fyy, which is 6, minus fxy, which is actually our fyy was negative 4 and our fxy was 6. So we'd have 6 squared. So let's write that down. So we would have 0 times negative 4 minus 6 squared, which is less than 0. And our fxx, since it's less than 0, we don't need to worry about it, because if d is less than 0, it's automatically a saddle point. So we'll say saddle point. And now we do negative 3 comma negative 9/2. I'm just going to write down what it should be. So negative 18, negative 4, minus 6 squared. So this is 72 minus 36, so it's greater than 0. And our value of fxx is negative 18. And based on the chart, we have a positive D and a negative fxx, so it's a local max. So we can write local max. And this is all we need to do for this problem.